Hello everyone, welcome to this demo that will demonstrate new feature of the server-side or cloud-based resolver offered by project Thoth. So here you can see our main page, that is thothstation.ninja, and if you browse documentation and you go to get started or to the advisor documentation, and here you will find configuring and setting up advisor in a cluster, and you scroll down, you can see a new section that is called configuring solver rules. And what this section does, it basically describes how to configure solver rules and what are solver rules. So what are solver rules? These solver rules provide some configuration of the server-side or cloud-based resolver, and they configure which packages should be analyzed by the system and then subsequently recommended to users. Here you can find an example entry. So it's a JSON that states name of the package that in this case is called setup tools. And this solver rule states that any setup tools package or setup tool release that is below version 20 should not be analyzed by the system and should not be recommended to users. Moreover, this rule applies only if the given package is obtained from pypi.org. There's also a description for maintaining the solver rule. This rule can be additionally configured. So if you remove any version specifier or you provide version specifier as null, this solver rule will apply to all the setup tools packages regardless of their version. The same or the similar applies to index URL. So if you do not provide index URL, then the given solver rule is not specific to any Python package index and applies only to pypi.org. Then you have description. If you configure a solver rule, that means two things. So as stated, it configures which packages will be analyzed by the system. So if you specify this type of rule, there will be no solvers run to analyze these older releases. So by doing so, we first do not analyze packages that do not have assigned or are not interested from Thoth point of view. So if these are old setup tools that are no longer supported and are no longer required in runtime environments that we provide recommendations on, then we configure this solver rule, and the system does not analyze such packages. And also the system will not use any cluster resources for analyzing. So cluster resources can be used more effectively, and there can be analyzed packages that are relevant to the specific users or data aggregation that Thoth should do. So here you can see a solver rule entry. This entry is configured on management API. So if you go to deployment and you browse management API and you scroll down, you can see Python solver rules section. In this case, you can list solver rules, you can list all the solver rules, or you can list solver rules that are specific to a package, that are specific to some index, that are specific to both package coming from some specific index. And then there are also, you can also apply There is also endpoint for applying a new solver rule, so a Thoth operator can apply a new configuration to deployment, and you can also delete solver rules or get by identifier. These solver rules are applied when it comes to data aggregation, so the system does not analyze packages and the releases that are not relevant to the system, as well as if you apply a solver rule, that means that the recommendation engine will not recommend packages that correspond to these solver rules and will automatically remove them from the software stack. This removal is then seen in the resolution log, and if you browse the resolution log, you can see messages and descriptions that are stated there. Okay, so as a first step, we did aggregation of data of Python packages that are available on PyPI. So we downloaded information about all the packages that are available on PyPI and did some data mining, very simple data mining, and obtained information about packages released on PyPI. So here you can see a Jupyter notebook. This Jupyter notebook is present in ThothStation organization under notebooks repository. If you go to notebooks development directory, here you can see gathered PyPI package info. That is the notebook that I'm showing. The notebook uses data that are available to Thoth members. You can find this data on Thoth, Thoth that is on or is provisioned on OCP4 cluster. But basically, from the all information of packages that PyPI provides, we extracted information about release date or upload time of the given release, and we plotted results. All these artifacts that are available on PyPI are dating back to 2005, so March 2005, and the analysis was done in June. So these data corresponds to this time frame. So here you can see a number of packages or releases that were published on PyPI starting from March 2005 to June 2021. As you can see, number of packages are increasing over time, and the x-axis has no labels. As you can see, it's pretty dense bar chart, but basically each bar in this bar chart corresponds to 1 month. And so the very first bar will correspond to March 2005. The last bar corresponds to June 2021. As the data aggregation was done early in this month, the bar is pretty small. Yes, there will be definitely new releases published. So here you can see the number of releases are growing on PyPI. And then there was picked one marker or one point in time, that is December 2016, when Python 3.6 was released. And this was taken as a marker for which we split the original bar chart into 2 parts. So the first part shows packages or releases published starting December 2016 to June 2021. So here you can see that it's not that dense bar chart, and you can see the head of the bar chart. So each bar again corresponds to 1 month starting from starting from December 2016. And then we have the first part that is basically the tail. This table shows releases published on PyPI starting March 2005 to December 2016. So here you can see the tail, and now why this work was done. We basically wanted to remove packages or releases that were too old. So if some package was released before December 2016, we considered it as too old to be consumed by users, too old to be recommended to users, too old to be analyzed by system. So we don't need to invest time into analyzing packages that are not used. And thus, solver rules were created for our environments, and this way our environments analyze packages that are more recent and do not care about old releases. The next step of this work is basically analyze packages with respect to usage. How are they used now, and how these older releases are used, because we found, for example, if we take a look at a package that is called termcaller, we see that it is still used. For example, it's used by TensorFlow and it's present in TensorFlow stack, but the most recent release dates back to January 2011. So this way we basically had to explicitly allow analyzing termcaller and allow the system to learn on this package. So there are possibly other packages that can be unblocked. So we should analyze packages or releases that are still used, even though they are older. And we should also analyze package usage of newer packages, or how they are maintained, so the system does not analyze these packages and rather invests time into analyzing packages that users use and the recommendation engine produces. So here you can see configured solver rules. These solver rules are also part of init job, that is the initialization job done or scheduled on a new or fresh Thoth deployment. So here you can see, besides other things that the init job does, you can see solver rules JSON, that is JSON stating solver rules that are configured if a new Thoth is provisioned. So this way, I would like to thank you and see you next time.